Okay, so before we begin, we need to remind everybody that the sine of 2 theta is the same as 2 sine theta cosine theta. That is important when we have to use the power reducing formula in our integration. Yeah. All right. What's wrong with our integral?
X.
Lots of x's. Okay, so first of all, is u to u substitution possible? Because when possible, that's definitely the way to go, right? Okay, not possible. Bill. So we have the square root, and we have some x's underneath. There's some subtraction there. What are we going to have to do? Okay, so first of all, if we're going to do some rules or some trig substitution, we need something squared minus something squared underneath, or something squared plus something squared. So we're going to need to complete the square. All right, get my emphasis there. So let's look at 4x minus x squared. Okay, and we're going to complete the square.
Add 4.
Okay, well, first of all, let's write it like this. And can we complete the square if our coefficient is -1? No, no.
So Willie's.
It was your pre-calc.
I like you,
I know.
actually.
I know.
Just call it like 2 minus x squared. Wait.
You cannot complete the square
Yeah.
unless the leading coefficient is 1. So now I have fixed it. Our leading coefficient is 1. What number completes the square? So we cannot just add a number. We have to add it and subtract it. But we're really adding -4. So we have to subtract a -4. So this is negative x minus 2 squared plus 4. Back to our integral. So our integral is x squared over the square root of 4 minus x minus 2 squared. Yes. So this looks like an opportunity to do what kind of integration?
Trigonometric
Okay,
sine.
I think it would be sine, right?
2 sine of 20 x minus 2.
We have 2 squared minus x minus 2 squared. So we have a squared minus x squared, essentially. Okay? So whatever is being squared, that's what we said equal to this, to a sine of theta, right? So different color. X minus 2 equals 2 sine of theta. Okay? Just like yesterday we made like 2x equals 3 tangent theta or something like that, right? Yes? Okay, so differentiate dx is 2 cosine theta d theta. And oh, that's not usually how I draw them. Apologize. Doesn't matter, but I like to be consistent. So our sine ratio is x minus 2 over 2. So this is 4 minus x minus squared. Okay. So far, so good? Okay. Now the fun begins. So first of all, we need to replace x squared. 2 sine theta plus 2, the quantity squared. We're going to replace x minus 2 squared with 2 sine theta. So this becomes 4 sine squared theta. And then we replace dx with 2 cosine theta.
Yes, minus.
Oh, I wrote plus. Thank you. Sometimes talking and writing at the same time, I get jumbled. What? Okay, are we all... We've done this a few times. What is this denominator going to become?
2 cosine. Well, it cancels with the 2 cosine up there too, so we're going to be left with the 2 squared.
And what is 2 sine of theta plus 2, the quantity squared?
Cancels itself.
4 sine squared.
8 sine.
Oh, okay.
8 sine.
Oh, but what happens?
It all breaks apart now.
That goes away.
So then the sine squared of theta is in.
Oh, no.
Okay, so now we have, I'm going to bring out a 4, and we have sine squared theta plus 2 sine theta plus 1 d theta. But, can we integrate sine squared by itself?
Guessing no.
We're just power changing.
Okay, we cannot integrate sine squared by itself, which means we need to do the power reducing formula. And what is that power reducing formula for sine squared? All right, here it is. We have 4 times. Are you okay with me adding 1/2 and 1 together? Make 3 halves, and when we integrate it, we get minus. When we take the antiderivative of 1/2 cosine of 2 theta, plus a negative 2 cosine of theta.
Other change.
You see why I like the whiteboard? What is the issue now? We have this 2 theta, and our triangle is only in terms of theta. So we need to change sine of 2 theta using that identity so that it can be in terms of theta. So if the sine of 2 theta is the same as 2 sine theta cosine theta, then this becomes 1/2 sine of theta cosine of theta. And to get rid of these fractions, I'm going to multiply the 4 through. So 4 times 3/2, 4 times 1/2, that works, right?
That is a long.
Oh, we're not even done.
No, I mean, I have the answer.
Okay, 6 theta.
Oh, boy.
Hello, triangle. We missed you.
X over 2 minus 1.
Okay, so to get theta, we need to divide by 2 and then take the inverse sign. So theta is the same thing as the inverse sine of x minus 2 over 2. What is the sine of theta? What is the cosine of theta? That square root thingy over 2. Minus 8 times the cosine of theta again, right? So to make this look pretty, we have 6 arc sine of x minus 2 over 2 minus,
You dropped a 2 somewhere, I think, because I have 2x minus 2 square root of 1 minus x minus 2 squared. And I preserved my coefficients inside the integral all the way through. So either I have 2 that can do
I got the same thing as her, and I
Yeah.
kept my coefficients.
So where did I drop my coefficient?
You lost a coefficient somewhere.
there's a little bit of satisfaction at the end of that answer. We did it. We made it. We used up a lot of board space, but we did it. It's true. I didn't use an E. Okay? But it wasn't so bad.
Let's go with
We
that
only
one.
have 20 minutes left in the presentation.
Okay? You are to a point in your mathematical careers. Will probably take a little bit longer to happen.
Hour and a half on homework assignment is a long time.
Yeah, we did that.
Let's talk about index.
Okay, this is where it gets nice. I'll make this big. Okay? Just like in U to U substitution, okay? We can, if you remember back, we looked at it where we did the substitution, we changed everything back into X, plugged in our limits of integration. Or we looked at it when we made the U substitution, we changed our limits to in terms of U, and then you don't have to go back to X. We did the same thing here. Okay? So, this is going to save us some time if we change our limits of integration. Okay, going back to the triangle and rewriting everything and then plugging things in sometimes can get a little complicated. Okay, so we can save some time by changing our limits of integration. So first of all, okay, you look at this problem and you see, I see x squared and I see x cubed. That's going to work out nice. But they're in the wrong places, aren't they?
Yeah.
Okay, but I see the x squared plus 9, and that should be a light bulb for you to make x which means dx so our tangent ratio is x over 3. Whoa, sorry. I said tangent. I know. I said tangent and I labeled sine. There we go. Okay, so if we are going to change our integral to be x cubed, so 3 tangent cubed, over the square root of x squared plus, excuse me, not x squared, 3 tangent of theta squared, so 9 tangent squared, plus 9. Dx becomes 3 secant squared theta d theta. Now, instead of coming back to that 0 and 3, those are x values, right? So let's talk about when x is 0. What is theta? So we have 0 equals tangent of theta. When is tangent 0? Right there, right? Okay. And then we have 3 equals 3 tangent theta. So where's tangent 1? Or is the first place that tangent is 1? Right? So now our limits of the integration are from 0 to pi over 4. Our denominator becomes what? Try again. Under the radical is 9 secant squared, so it becomes 3 secant. Up top we have 27 tangent cubed, and then we have times 3 secant squared. Okay? From 0 to pi. Okay, so these 3's cancel out. I'm going to put 27 on the outside here. This secant cancels out with one of these, so we have tangent cubed secant theta. You said we didn't do enough tangent secant examples, so here's another one for you. Okay, so
For integration,
yeah, if we want to integrate this, we can't do u du substitution yet.
Right.
Okay, so we'd want to change one of the tangent squares. Tangent squared is
secant squared plus 1. I think it's secant squared plus 1. I'm gonna go look.
I got 3 different answers.
Secant squared minus 1. Secant squared minus 1.
Yes.
Everyone was confident, which I appreciate. So let's remember it correctly.
We were close.
What?
We still were close. Doesn't really matter.
So now U needs to be what? So du is, and there that is. So we have 27 integral of u squared minus 1 du. Do you want to?
No.
Why not?
Okay, we'll come back to it. So this is a nice integration now, isn't it?
Yeah.
Now we have 27 times 1/3 secant cubed minus secant. Evaluated from 0 to pi over 4.
Secant is 1 over cosine.
Secant is 1 over cosine,
So it'd be 2.
which would just be radical 2. So we have 27 times 1/3 radical 2 cubed minus radical 2 minus what is the cosine of 0? So this becomes 27 radical 2 cubed.
8 squared root 2.
So this becomes 2/3 radical 2 minus radical 2 minus -2/3.
Negative 1/3 radical 2/3.
So what's 27 times 2/3?
18.
Excellent. What's 2/3 of something minus 1 of something? Times 27. Hey! We did it.
Go get my shield and I
That's ideally your answer. Okay. So this is fun, right? So I'm going to give you a homework assignment. You're going to have some problems where you're going to need to potentially complete the square. You're going to have some problems with some limits of integration. On Monday, I'm going to give you just kind of a work day with more problems to brush up. Okay? And Tuesday we're going to have a quiz. All right?
I know. In my second calculation, I still kind of filled out. And this is fine.
I could probably stop this.